In this unit section, we are going to be looking at variation equations of different types. The first one we're going to look at is of the form y equals kx, where k is a non-zero constant. This is a special group of linear equations, meaning that they would form lines, and these are called direct variation problems. So let's suppose that you're earning $8 an hour at a part-time job. The amount of money you earn depends on the number of hours that you work. Below, you're seeing a table. If you work 0 hours, you earn 0 money, and 1 hour we're earning $8, 2 hours 16, etc. So as the number of hours worked increases, the money that you earn also increases. You can see this from the table. So let's put an equation to this. If we let y represent the money earned, so this is going to be our y column, and x represent the number of hours that we worked, we're going to write an equation that fits this. Since you earn $8 an hour, this would just be y equals 8x. So for direct variation problem, it's said that y varies directly as x, or y is directly proportional to x, if this holds true, so that we have y equals k times x. The number of k is very important. This is called our constant of variation. Now let's take a look at an example. We're seeing another table here, and we're supposed to notice the pattern following this. If you notice, as your x increases, so does your y. What we're wanting to look for is that constant of variation. So we're wanting to follow the format y equals k times x. So 6 would be k times 2. Solving this just as a normal equation, we would get k to be 3. We can verify this with each of the others. 27 would have to be k times 9. So again, we get k to be 3. 4.5 would need to be k times 1.5. Again, k is 3. Finally, negative 3 would be k times negative 1. So again, k is 3. Since each point in this fits the same pattern with the same constant of variation, this would be a situation of direct variation. We could write our equation using our constant variation, and it would just be y equals 3x. Okay, so let's look at the next example. Suppose that y varies directly as x, and now we're told that y is 17 when x is 3. My job is to find the constant of variation and the direct variation equation, and then I'm going to use those to find x when find y when x is 10. Below, you're seeing step-by-step instructions on how to accomplish this problem. The first thing you're always going to do, because as we add more variation, this can be different. We're going to write the general form for direct variation. So we're going to write y equals kx. This is our general form. The second step says to fill in values and calculate the constant of variation. So we're going to use the information that I circled above. We're told that y is 17 when x is 3. Solving for k, we're going to find out that k would be 17/3. This is our constant of variation. So you need to be able to answer questions about each different piece of the equation. Now we're going to reset our equation. I know what k is, so I'm going to write a specific equation now using my k value. This is our equation of variation. Finally, we're going to move on to our specific task. Our task is to find y when x is 10. So I'm going to change x to 10 and simply calculate the value of y. So if you look here, I know that my constant variation is 17 over 3. I know that my equation of variation is y equals 17/3, and I know that the answer to the question is 170 over 3. You need to be able to understand what each part of this means and how to find the answers. Now let's move on and look at a word problem. Example 4 says the weight of a load of bricks varies directly with the number of bricks in the load. If the a load of 500 bricks weighs 1,175 pounds, what will a load of 1,200 bricks weigh? Keep in mind there is more than just the answer that we want you to be able to find. For every problem, you should be able to identify a constant of variation, an equation of variation, as well as the answer. So if you follow that process that we just modeled, you should be able to find each piece. So the first thing we need to do is identify our general form of the equation. The hint below tells you to use the first letter of important units rather than x and y. This makes your substituting easier. So I'm talking about the weight of a load of bricks, and it says that it varies directly with the number of bricks in the load. That's what's going to give me my general form of my equation. So I'm going to say that the weight varies directly as the number. I've always got that k value in there so I can find my constant of variation. Now what I'm going to do is substitute in the information that it gives me. It tells me that a load of 500 bricks weighs 1,175 pounds. So the weight is 1,175. The number would be 500. If I go solve this for k, what I'm going to get is the fraction 47 over 20. Now we're going to take this and substitute in. We're going to reset our equation, plugging in our constant of variation. So we've got 47 over 20 times n. Oops, I said that correctly. I wrote it wrong. Make sure that you have the correct constant of variation. So now what we're going to do is find our specific answer. My task is to find out what a load of 1,200 bricks is going to weigh. So I don't know the weight. There's my constant of variation, and all I need to do is plug in the 1,200 for my number of bricks. Calculating this out, we're going to get 2,820. So the answer to the question would be 2,820 pounds. Always make sure that you include units on your final answer. Now stop the video, read the next problem, and try that one on your own. Your teacher will check this next class period. Let's move on to example 5. The surface area of a cube, and we're going to use A for surface area, varies directly as the square of the length of the side, S. Okay, be careful here because it says the square of the length of the side, not just the length of the side. So when we write our general equation, we're going to have A equals K times S squared because that's what the problem tells us to do. Now I can take this general information that they give me. They tell me that A is 54 when S is 3. I can plug that in and do the calculations. Make sure you square before you multiply. So this becomes 9K. Divide, we're going to get K to be 6. That's our constant of variation. Now we can reset our equation, and it's going to be A equals 6S squared. And then we can complete our task. Our task is to find A when the side length is 4.2. Again, that squared is part of the equation, so you're going to need to calculate that. Doing the calculations, you should get A to be 105.84. Okay, so since this is area, it would be in square units. They don't give us any particular measurements, so we're just going to say square units. Now it's your turn. Stop the video and try the following problem. When you get back to class, your teacher will check that with you. Okay, let's move on to inverse variation. Inverse variation is similar to direct variation. You'll go through the same steps, but your basic equation is different, so you'll need to read very carefully to figure out if you're dealing with direct or inverse. If y varies inversely as x, or y is inversely proportional to x, we would have the general equation y equals k over x. K is still our constant of variation, sometimes also called a constant of proportionality for inverse variation. So let's look at example 6. The equation of variation we're looking at here is y equals 12 over x. This is inverse variation because x is on the bottom of the fraction. So we're going to fill in the following chart. They started it for you. If I plug in 1/2, remember what we do is 12 divided by 1/2, which would look like this. So we can flip and multiply. That's where the 24 comes from. The rest of those should be easy. 12 divided by 2 is 6. Go ahead and complete the chart. 12 divided by 4 should be 3. 12 divided by 6 is 2. And if you can see this backwards, you can get it, or you can actually just use an equation. I know that y has to be 1, and I'm trying to find x. So to solve this, just like we've been doing with our rational equations, we would multiply both sides by x. So that's going to give me x is equal to 12. So when I look at this, what I'm noticing for inverse variation is that when x increases, my y decreases. They're going to go in opposite directions. The constant of variation is still k, and in this case it's that number on top, so it's going to be 12. So let's look at an example. Example 7 tells us that y varies inversely as x. So this is our general form. And what we want to use to find our constant of variation is this information right here. Y is 2 when x is 100. Solving for k, I'm going to multiply the 100 across. So I'm going to get my constant of variation to be 200. So my equation of variation, when I reset that, is going to be 200 over x. So we would have y equals 200 over x for our equation of variation. Finally, what we need to do is follow through with the task. The task that we're given is to find y when x is 1,000. Okay? So we're going to go through and do that. And they're telling me x is 1,000, so I'm going to have 200 over 1,000. When I reduce that out, I'm going to get 1/5. So the answer to my task is 1/5. Let's move on and look at a word problem now. The ticket prices at a concert are inversely proportional to the distance from the stage. Okay, this is going to give us our general form. I'm going to use T for ticket prices, and I'm going to use D for the distance from the stage. So my ticket prices are inversely proportional to the distance from the stage. Make sure you got your K on top of your D. If seats are 10 feet from the stage, this is the information that's going to give us our constant of variation. Okay, seats are 10 feet from the stage, those cost $200. So the ticket cost is 200 when the distance is 10. When we solve, this is going to give our constant of variation a value of 2,000. So now we can reset our equation. T would be 2,000 over D, and we can complete our task. We need to find the price of a ticket 50 feet from the stage. The 50 feet is distance, so we're going to have 2,000 over 50, and that comes out to be 40. So the answer to the question would be $40. Okay, the next problem says try, so go ahead and stop the video. Read through that carefully, set it up, find your constant of variation, your equation of variation, and the answer to the question. When you're done, restart the video. Hopefully you're understanding the difference between direct and inverse variation, and this problem is making sense to you. The last page of your notes covers joint variation. This is really just a combination of direct and inverse. In class next time, your teacher will go through these problems with you, as well as make sure that you got the ones that you were supposed to have tried. Good luck.